Good morning. I am Manuel, and this is Science 10. The topic that I'm going to discuss about is the layers of the Earth and how the scientists discovered and studied such thing. So, without further ado, let's get started. Layers of the Earth. The layers of the Earth has two types: the compositional layer and the mechanical layer. The compositional layer consists of the crust, the mantle, and the core. The mechanical layers consist of the lithosphere, asthenosphere, mesosphere, outer core, and inner core. And then, the layers of Earth has boundaries which marks the interfaces in between them, such as the Bohorovicic discontinuity, Gutenberg discontinuity, and Lehmann discontinuity. The outermost compositional layer of the Earth is the crust. The crust is where life exists. It has two types: the continental crust and the oceanic crust. The continental crust is the crust that makes up the continents. It is composed of light granitic rocks made up of aluminum silicates. It is about 40 to 70 kilometers thick. The oceanic crust is the crust that underlies the ocean bed. It is made up of dense basaltic rocks composed of magnesium silicates. The average thickness of oceanic crust is about 5 kilometers. Underneath the crust is the mantle. The mantle is a semi-solid, rocky, and very hot layer of the Earth. It makes up 80% of it and carries most of its mass. It is composed of ferromagnesium silicates. Mantle is the thickest layer of the Earth. Beneath the mantle is the core. The core is a very hot, very dense center of our planet. The core is responsible for the generation of Earth's magnetic field. The core has two distinct layers. And now, we are going into the mechanical layers. The first one is the outer core. The outer core is the only liquid layer of the Earth. It is made up of molten iron and nickel. The inner core is mostly solid iron. It is very hot. Its estimated temperature is about 6,000 degrees Celsius. You might be thinking, why is the inner core solid while the outer core is liquid, despite the inner core having a much hotter temperature? It's because of the high amounts of pressure present within our inner core. That's why the irons remains solid intact. And did you know that the core is almost as big as our moon? The next one in the mechanical layers is the lithosphere. The lithosphere is comprised of the crust and the uppermost part of the mantle. It is a rigid layer that can break under stress. It is composed of major and minor blocks that is called the tectonic plates that interacts and creates tectonic activities. The lithosphere hovers above the asthenosphere. Under the lithosphere is the asthenosphere. The asthenosphere is about 180 kilometers thick. It contains of hot, molten rocks or magma. It can deform and reshapen driven by the heat energy. It circulates as the convection currents. Convection currents are the result of differential heating. Lighter materials or less dense rises, while heavier materials sinks. This creates a movement which is a circulation pattern called convection currents. Convection currents are present within our Earth's atmosphere, in the water, mantle, and or in the asthenosphere. The asthenosphere is partially molten and possesses a physical property which is called plasticity. The plasticity enables the lithospheric plates to hover and move towards the weaker, softer part of the asthenosphere. You can describe the asthenosphere as the soft plastic. Below the asthenosphere is the mesosphere. The mesosphere encompasses the lower mantle. The materials still flow in the mesosphere but at a much slower pace compared to the asthenosphere. The mesosphere can be described as the stiff plastic. Always remember that the mesosphere and asthenosphere are not liquid. And never confuse the mechanical layer, mesosphere, to the atmospheric layer, mesosphere. Going into the boundaries, we got the Mohorovičić discontinuity. The Mohorovičić discontinuity interfaces between the crust and upper mantle. The next one is the Gutenberg discontinuity. It marks the boundary between the lower mantle and outer core. Lastly, we got the Lehmann discontinuity. It is located between the liquid outer core and the solid inner core. Going to our second lesson is the mapping of the inner Earth. The scientists studied the interior of the Earth by the use of seismic waves. Seismic waves are created by tectonic processes such as earthquake, volcanic eruptions, and so the like, that they analyzed in order to determine the Earth's density, composition, and properties. They used a tool or device which is called seismometer. A seismometer is a sensitive instrument that detects seismic waves. It responds to the noise, shaking, and other things that the ground produces. They also used a seismograph, which is an instrument that makes a record of seismic waves. They use this in order to examine the motion of the ground. The recorded seismic activities are shared with other scientists in different parts of the world in order to classify the speed, frequency, and other factors of the seismic waves. There are two types of seismic waves. They are the body waves and surface waves. The surface waves travels through the surface only. The study of the surface waves enabled us to know the effects of an earthquake and so the like, but they does not provide much information about the interior structure of the Earth. The other one is the body waves. The body waves travel through the inner layers of the Earth. The study of body waves made us realize that there are various parts of our planet. There are two types of body waves. The first one is the primary waves. Primary waves or P waves are compressional waves. They are first to be felt on the Earth's surface. They are faster than S waves. Primary waves travels at a speed between 1.5 to 8 kilometers per second. P waves pass through solid and liquid. As what you've seen, P waves are compressional. They are longitudinal waves. They are first to be felt on the Earth's surface, hence the name primary. They are faster than S waves or secondary waves, which we will talk about later. Primary waves pass through solid and liquid. But when they go through liquid, they either get reflected, absorbed, or transmitted. And when they are transmitted, primary waves refracts or bends. Another type of body waves is the secondary waves. Secondary waves are transverse waves. They are in an up and down motion. They does not travel through liquid, and using this principle led to the discovery that the outer core is liquid. They are 60 to 70% much slower compared to P waves. Secondary waves are transverse. They are in an up and down motion perpendicular to their direction. S waves does not travel through liquid. Secondary waves give us the ability to perceive that the outer core is liquid. And S waves are 60 to 70% slower compared to the P waves. Let's do a recap. Layers of the Earth has two types, the compositional layer and the mechanical layer. The compositional layer consists of the crust, which is the outermost layer, the mantle, thickest layer, and the core, the innermost layer. And then in the mechanical layers, we have the lithosphere, which are slabs of rocks that are called tectonic plates, the asthenosphere, which has the physical property plasticity, below that is the mesosphere, and then beneath that is the outer core, the only liquid layer of the Earth, and the inner core, which is mostly just solid iron. Then we got the boundaries of the layers of the Earth, which is the Mohorovičić discontinuity. It is the boundary between the crust and the upper mantle, and the Gutenberg discontinuity, the lower mantle and outer cores interface mark. And lastly, we got Lehmann discontinuity, which is found in between the outer core and inner core. Scientists use what we call seismic waves in order to map the inner Earth and study its internal structure, such as its composition, density, and properties. In order to detect the seismic waves, scientists used a sensitive instrument which is called a seismometer, and in order to record the seismic waves, they used a seismograph. Seismic waves has two types, the body waves and the surface waves. Surface waves only travels to the surface, and then the body waves which travels to the inner layers of the Earth. The body waves has two types, they are the primary waves, P waves, or pressure waves. They are first to be felt on Earth and travels through solid and liquid. The other one is the secondary waves, S waves, or shear waves. They follow slowly with a swaying and rolling motion. And that's the end of my topics. Did you listen carefully? If you did, thank you. And that's about it. See ya!